presentation is about memory management, specifically about memory segmentation and paging. Why is memory allocation important?
That's an actual question. Why is memory allocation important?
Because of those bullets.
Okay, Eric, no one can hear you.
Without memory allocation, you wouldn't be able to run multiple programs at once, and your computer would be doing pretty much nothing.
It's almost as if you read it off the card I never showed you. You want some candy?
Sure.
Just toss me some. Well, you always want a specific piece, man.
Fine.
A whole hand.
There you go.
Small kid on Halloween, alright? Oh no!
Okay, so we're going to do a real quick review of paging. Paging is basically breaking up the virtual memory into blocks and loading those blocks into the physical memory. And of course your virtual memory will be a lot bigger than your physical memory. But one of the biggest issues of paging is that pages have fixed sizes. So if you think of address space as being like a stack, you have different sections of the stack for like your source code, the call stack, all your variables. But what happens if like one of those sections grows to be too big? It starts to run into the other sections of the stack, which is what segmentation, which we're going to talk about, tries to fix. So why is paging difficult to implement?
Also wanted the question. Where's an answer?
Got a bunch bar.
This is actually covered by group 2, kind of. Eric, want to go again? You know the answer. I know you do. You always know the answer. Fine. Crystal. Sorry, Crystal. So stupid. Answer the question. You also know the answer.
Yeah. Because you have to deal with wasting space because of the fixed size. So no matter what, you're going to be wasting some space usually.
All right. We'll steal some candy from Eric. I don't feel like walking over there again. Awesome. You got some.
All right, so the next type of virtual memory management that we're going to talk about is segmentation. It's when you divide memory into blocks. And it's more of a logical entity way to do it instead of, whereas paging is more of a way to get more memory out of a limited amount of physical memory. Segmentation is used more to simplify programming and memory management than just to increase the amount of memory that you have. So why could it be wasteful?
Or how is it wasteful?
To be given a block that's bigger than it actually ever uses.
What? Eric, grab the handful, man. Come on. Pretend I have to carry this around the rest of the day. Thank you. 2. My 20-pound bag of candy is now wet. Thank you. All right, hit the space bar. I'm pretty sure mine is next. Yes. All right, so this one's going to be a bit of a headache because this is straight from the textbook. And don't worry, this is going to go away in like 5 seconds. I just want everyone to quick use photographic memory that I know you all can do and have to just memorize this chart. And hopefully my animation works. There it is. All right, so that went away. Ooh, look, we have an empty block. Sorry, it's going a little bit slower than it usually does. Man, why are those going faster? Whatever. So basically, each of those represented programs, now they're being taken away with the empty space, and new programs are taking their places. At the end of this situation, or the whole run, we would then reallocate all of the programs go down, and now we have 10K of empty space. Before that, we just had several smaller blocks of empty space. You have a question?
Yes. I mean, well, it's not really a question, it's like a rhetorical statement. So you like basically defragment your memory?
Not automatically at the end of it. That's something you would have to do purposefully, but that was going back to the previous question of how it would waste space. Because now you have a bunch of these smaller chunks of memory. Until you perform that task, which is the moving the segments around, you just have smaller bits like, what is it, in Ks? So like 1 kilobyte of memory that's just sitting there. What program uses 1 kilobyte? Nothing. That's what.
It is a little bit similar to that, or garbage collection or something like that.
Okay. Alright, cool. I didn't even do anything.
My presentation take longer.
So Multics, Multics is known as Multiplex
You can have all the
Information Computing Service, and it started in 1964 in Cambridge, Massachusetts. And it was one of the first operating systems to implement segmentation and paging. So, designed as a time-sharing operating system, which means the sharing of a common resource among multiple users via multi-programming, multitasking. That means that multiple people use computers at the same time. And Multics greatly influenced the Unix operating system, which is why the Unix operating system actually uses segmentation and sharing, as well as a hierarchical file system shell, and the security that you see in Unix systems. It was also, of course, the first operating system to implement paging and segmentation.
So we got a small video.
What are we going to talk about the GUI?
Whatever. You do that first.
Sure, why not?
Okay. You want to talk
Right, because it talks about Multics. There wasn't a way to put a link to the GUI inside the slide, so it's very out of order.